Hello everyone. Today I am here with you all with 7th chapter of class 9th maths curriculum, that is your triangles. We are already having videos on first 6 chapters of class 9th maths. So let's start with the 7th chapter, that is your triangles. Before starting with the triangles, let's understand what triangle is. As we know, triangle is a polygon. What polygon is? Polygon is a closed figure which is only made up of line segments. And we know that the meaning of tri means 3. So triangle is a closed figure or it is a polygon with 3 sides. Suppose I am going to say that this is your triangle ABC. This is your A, this is your B, so this is your C. So a triangle is having 3 vertices, 3 sides and 3 angles. So this A, this B and this C, these are known as your vertices. So triangle is having 3 vertices. Over here we can say A, B, C are the 3 vertices. It is having 3 sides. So which are the sides over here? AB is one of the side, BC and AC are the sides of a triangle. So sides will be your AB, BC and AC are the sides of the triangle over here in this triangle ABC, and these are your angle A, angle B and angle C. So triangle is having 3 vertices, 3 sides and 3 angles. Like this we can see over here. We have already seen the properties of triangle in chapter number 6, that is sum of all the angles of a triangle is 180 degree. It is angle sum property of a triangle which we have learned in 6th chapter, that is your lines and angles. Here in this chapter we will be learning about congruency of triangle. So what congruency is? Congruency means the things which are exactly same. That is, in all the respect, if there are 2 things which are exactly same in all the respect, then we say these 2 things to be congruent. Now, if we are going to compare the figures, if there are 2 figures which are exactly same in the shape also and in the size also, then we say that these 2 figures are your congruent. Now, let's compare some of the things. Suppose I am going to say that there are 2 circles are there, and for both the 2 circles radius is your say 2 centimeter. If there are 2 circles whose radius are 2 centimeter, then if we are going to keep one over the other, they are going to exactly overlap each other. So such type of circles with the same radius are known as congruent. That means if we are having 2 figures and we are going to cut it and we are going to keep one over the other, and if they will be exactly overlapping each other, then they are said to be congruent. So if we will be taking any 2 circles with the same radius, they will be congruent. Similarly, if I am going to say that I am going to compare a square with another square whose sides are your 3 centimeter. For this square also, all the sides are 3 centimeter, and for this square also, all the sides are your 3 centimeter. Suppose this is your square ABCD and this is your PQRS. So I'll be saying that this square ABCD will be congruent to square your PQRS, because in both the cases, in both the squares, your sides are same. Similarly, if I'll be taking 2 equilateral triangles with the same sides, one of the triangle, another triangle I have taken, this is your ABC triangle, this is your PQR triangle, and these are equilateral triangles, and if I am saying the side of both the 2 equilateral triangles is your 4 centimeter, then these 2 triangles will be congruent. That means if I will be cutting these 2 triangles and I will keep one over the other, they will be congruent, they will be exactly overlapping each other. Now, whatsoever the regular polygon I will be taking, regular polygon means that all the sides of that particular polygon will be of the same measurement. So if I'll be taking any 2 regular polygon should be with the same number of sides, then they will be overlapping each other. Regular means all the sides will be of equal measurement, and if number of sides in both the 2 polygons which we are comparing is same, in that case they will be overlapping each other, they will be congruent to each other. Similarly, whensoever we have to generate any identical items, like ice cream molds could be there, your whatsoever the identical things, if we have to generate, they are even using the molds, and it is even on the concept of your congruency only. So here we'll be learning about congruency of triangle in this chapter. What congruency is, hope it is clear to you. Whensoever there are 2 figures we are taking with the same size and with the same shape, they are said to be congruent. and if they will be congruent and if we are going to keep one over the other, they will be exactly overlapping each other. So this is what congruency is. Now, if we are going to talk about congruency of triangles, so whatsoever the congruency of triangle means is, that means corresponding sides and corresponding vertices of two triangles, if they are equal, corresponding sides and corresponding angles, not vertices, it will be angle. If there are two triangles and corresponding sides and corresponding angles of these two triangles, if they are equal, then the triangles are said to be congruent. Over here it is not given to you that it is an equilateral triangle. Triangle is not compulsorily be equilateral in all the cases. Suppose this is a triangle, say ABC, and this is another triangle, say PQR. Okay, over here I'll be taking Q, over here I'll be taking R. So one of the triangle is your ABC, another triangle is your PQR. If AB is equivalent to 2 centimeter, BC is equivalent to 3 centimeter, and AC is equivalent to 4 centimeter. Similarly, over here PQ is equivalent to 2 centimeter, your QR is equivalent to 3 centimeter, and PR is equivalent to your 4 centimeter. Suppose this angle is your 70 degree, this angle is your 50 degree, and this angle is your 60 degree. Similarly, if this angle P is 70 degree, this angle is 50 degree, and this angle is your 60 degree, in that case we will be saying that these two triangles are congruent. Because see, AB is equivalent to your PQ, BC is equivalent to QR, and AC is equivalent to PR. Similarly, angle A is equivalent to angle P, angle B is equivalent to angle R, and angle C is equivalent to angle B was equivalent to angle Q, and angle C is equivalent to your angle R. So we will be saying that triangle ABC is congruent to triangle PQR. This is the sign for the congruency. If these two triangles are congruent, we will be writing it as triangle ABC is congruent to triangle your PQR. Over here, your corresponding word is very important. That means if we are saying the triangle ABC is congruent to triangle PQR, that means your first, that is coming your A here and P here, that means A will correspond to your P. Second is your B and Q, so B will correspond to your Q, and C will correspond to your R. That means if I'll be keeping P over A, Q over B, and R over C, then they are going to exactly overlap each other. If instead of triangle ABC, I am saying, suppose over here, if I am saying triangle ABC is congruent to triangle QPR, then it is not true. It is not true. Reason being, A is not going to overlap Q, B is not going to overlap P, and C is not going to overlap R. That means corresponding word is very important. If I'll be keeping A over P, B over Q, and C over R, then only they are going to overlap each other. If instead of A, if A will be overlapping on B, B will be coinciding on P, and C over R, then they will not be overlapping each other exactly. That's the reason they will not be congruent. That's the reason writing its order, the order of this symbolically, if we are representing it, its order is very important. The correspondence is very important while we are writing it symbolically. So by this, what we can conclude is that A is corresponds to your P, B corresponds to Q, and C corresponds to R. Similarly, AB first two and PQ. AB corresponds to your PQ. BC corresponds to your QR, and AC corresponds to your PR. That means if I'll be keeping AB over PQ, BC over QR, and AC over PR, then they will be overlapping each other. So whenever we are writing it symbolically, like this triangle is congruent to this triangle, the order, the correspondence should be taken care of. This simply means it is very, very important while we are writing it. So correspondence simply means your A corresponds to P, means A will be overlapping P. P corresponds to Q, B will be overlapping Q, C will be overlapping R, AB, side AB will be overlapping PQ, BC will be overlapping QR, and AC will be overlapping PR. If instead of this I am writing this, then see AB and QP. AB is 2 and QP is your again 2 over here. Then your BC and your PR. BC is 3 and your over here PR is 4. This BC is 3 but PR is your 4. So they are not going to overlap each other. That's the reason this is a wrongly written. Similarly, if I am going to take one more example, say I am saying this is a triangle, say DEF, and this is a triangle GHI. If this is, suppose I am saying 2 centimeter, this is your 5 centimeter, and this is your 6 centimeter. Similarly, in this case, it is your 2 centimeter, then it is your 5 centimeter, and it is your 6 centimeter. So we won't be writing that triangle DEF is congruent to triangle GHI. It is not true. It is not correct, because see DE is 2 and GH is 6. So it is not corresponding. D is not corresponding to your this part is not come. DE is not overlapping your GH. That's the reason it is not the way we are going to write it. How we will be writing it? Triangle DEF is congruent to. Now see DE is your 2 and over here GI is 2. So we will be writing GI and then I'll be writing H. Now check it. DE is your 2, GI is 2, EF is 5 and IH is 5, DF is 6 and your GH is 6. That means D will be corresponding to your G. The point D will overlap on G. The point E will overlap on I and the vertex F will overlap on your H. This is how we will be writing it. And when we are saying that triangle DEF is congruent to triangle GIH, that simply means D corresponds to your G, your E corresponds to your I, and F corresponds to your H. Or we can say DE will be equivalent to your GI, EF will be equivalent to your IH, and DF will be equivalent to your GH. This will be the condition. And whenever we are proving that two triangles are congruent, so the corresponding parts will be equal. Corresponding parts means your corresponding angles will be equal, your corresponding sides will be equal. That means we will be using the term CPCT, corresponding parts of congruent triangles. If there are two triangles which are congruent, then their corresponding parts will even be equal. So because of any of the reasons, if we have proved it, that these two triangles are congruent, so by default we can conclude, we can write that by CPCT their corresponding parts will even be equal. That means your angle D will be equivalent to angle G, angle E will be equivalent to angle I, angle F will be equivalent to angle H. Similarly, side DE will be equivalent to GI, side EF will be equivalent to IH, and side DF will be equivalent to your GH. This is what the congruency means, and this is very important to maintain their correspondence. Now we'll be learning about some of the criteria of congruency of triangles. Now let's understand some of the criteria of congruency of triangle. As just now we have said that if the corresponding parts, that means corresponding sides and the corresponding angles of two given triangles are equal, then we say that these two triangles are congruent. Now instead of proving all these 6, that means all the 3 sides and all the 3 corresponding angles to be equal, there are few criteria also because of which we can say that the triangles are congruent. That means instead of proving all the 6 equal, if any 3 are equal, not only any 3, some particular 3 criteria, 3 elements of a triangle are equal, then also we can conclude, we can say that the triangles are congruent. So what all these conditions are, let's understand it. First is your axiom 7.1, that is your SAS congruency rule. SAS refers to your side angle side congruency rule. According to it, two triangles are congruent if two sides and the included angle of one triangle are equal to two sides and the included angle of other triangle. That means if there are two triangles are there, this is one of the triangle and this is another triangle. Suppose this is your triangle ABC and this is your triangle PQR. So according to your SAS congruence, if two sides of this triangle are equivalent to corresponding two sides of this triangle, that means AB is equivalent to suppose PQ and BC is equivalent to your QR, and the included angle of these two sides, for the side AB and BC, included angle is your angle B, and for the side PQ and QR, included angle is your angle Q. That means if angle B is equivalent to angle Q, in that case these two triangles will be congruent. So two triangles are congruent if two sides and the included angle of one triangle are equal to two sides and the included angle of the other triangle, then these two triangles are said to be congruent by SAS congruency rule. Now that simply means two triangles are given to us. The two sides of one triangle is equivalent to the corresponding sides of the another triangle, and the included angle of this triangle is equivalent to included angle of this triangle, another triangle. Then we say that the two triangles are congruent by SAS rule. Over here it is very important that the angle which is equal should be the included angle. If instead of angle B and angle Q, if it is given angle C is equivalent to angle R, in that case we cannot say that the triangles are congruent. That simply means your angle which we are considering should be the included angle. Which two sides are given equal, the included angle should be equal. Any other angle if it is given that this angle A is equivalent to angle P or angle C is equivalent to angle R, then we cannot predict, we cannot interpret that these two triangles will be your congruent. That simply means S side, A angle side. SAS congruency works, but your SSA congruency does not work. Which works is your SAS congruency works. Your SSA side angle or angle side congruency does not work. It should be your SAS only. Angle should be the included angle only. The two sides which are equal, the angle which we are taking into consideration should be the included angle only. Then we can say that these two triangles will be congruent by your SAS congruency. Now once we have proved that these two triangles are congruent by SAS congruency, then by CPCT, corresponding parts of congruent triangles, we can conclude that the remaining corresponding parts of the two triangles will even be equal. Here which triangle is congruent to which triangle? Triangle ABC is congruent to triangle PQR. That means A corresponds to P over here, B corresponds to Q here, and C corresponds to R. AB corresponds to your PQ, BC corresponds to your QR, and AC corresponds to your PR. We can see AB is equivalent to PQ, they are corresponding. BC is equal to QR, they are corresponding, and angle B is equivalent to angle Q because B and C are corresponding. Now this is given to us in the question, this is given to us in the question, this is even given to us in the question, but these are not given. But because we have proved that the triangles are congruent by SAS congruency, we can say that the remaining corresponding parts will even be equal. That means by CPCT we can say that angle A will be equivalent to angle P because A corresponds to P. Similarly, angle C will be equivalent to angle R, and AC, side AC will be equivalent to your side PR. This we can interpret directly by your CP/CT. Now let's see one of the questions from your exercise 7.1. That is your question number 1. In quadrilateral ABCD, AC is equivalent to AD. It is given to us that AC is equivalent to AD and AB bisects angle A. AB bisects angle A. Show that what we have to prove is triangle ABC is congruent to triangle ABD. This we need to prove. Now, what can you say about BC and BD? We have to interpret about BC and BD also. Now, let's make the figure. This is given. Here it is your like this. This is your point A. This is your point C. It is B. It is D. This side is given equivalent to this side, and this angle is given equivalent to this angle. Now see, it is given that AC is equivalent to AD. AC is equivalent to AD. It is given. AB is bisecting angle A. So this AB is bisecting angle A. That means your angle 1. Suppose this is angle 1 and this is your angle 2. That means your angle 1 is equivalent to your angle 2. This is even given to us, and it is even given that AC is equivalent to AD. It is also given to us. We have to prove that triangle ABC, this triangle is equivalent to your congruent to your ABD. So we will be considering these two triangles. So in triangle ABC and triangle ABD, over here A corresponds to A, B corresponds to B, and C corresponds to D. Now see, in these two triangles, we are considering this triangle and this triangle. These two triangles we are considering. In these two triangles, first ABC. In this triangle, your side AB is coming. So this AB is equivalent to your AB of this triangle ABD, because this AB is common for both the two triangles. So this AB is equivalent to AB. It is common for both the two triangles. In triangle ABC, your side AC, and triangle ABD, your side AD is equal because it is given to us. It is given that these are equal. Angle 1 of triangle ABC is equivalent to angle 2 of triangle ABD. It is even given to us that it is bisecting. AB is bisecting the angle A. So it is even given to us. So we can say your side, angle, side of this triangle is equivalent to your side, angle, side of this triangle. So we can say by SAS congruency, triangle ABC will be congruent to triangle your ABD, and hence proved. Now we have to interpret about your BC and BD. This is your BC and this is your BD. If you are going to see the triangles, BC corresponds to your BD. BC of triangle ABC corresponds to your BD of triangle ABD. So we know once we have proved that the triangles are congruent, then their corresponding parts will be equal. That simply means if we are going to check from here, this angle A, that is angle A1 is equivalent to angle 2, that we already know. This angle B, that means this angle 3 and this angle 4. Angle 3 will be equivalent to angle 4, and if this is your angle 5 and this is your angle 6, then angle 5 will be equivalent to angle 6. Corresponding angles will be equal. By CP/CT we can conclude it, although it is not asked in the question. And then corresponding sides will even be equal. This was already given equivalent to this. This was common for both the two triangles. So remaining side, your BC will be equivalent to your BD, because they are corresponding parts of the congruent triangle. So this is how we will be using the congruency rule, and we will be proving the questions. Now let's understand another congruency rule. Theorem 7.1. ASA congruency rule. Just now we have learned your SAS congruency rule. Now we are seeing your ASA congruency rule, that is angle, side, angle congruency rule. Now if there are two triangles are congruent, if two angles and the included side of one triangle are equal to two angles and the included side of the other triangle. That means if there are two triangles in which two angles and the included side of one triangle is equivalent to two angles and the included side of the other triangle, then these two triangles are said to be congruent by your ASA rule. Because it is a theorem, so we can prove it. So how we can prove it? Let's see it. So it is given to us that there are two triangles are there. One is your triangle ABC, another is your triangle DEF. In triangle ABC, angle B is equivalent to angle E of triangle DEF. Similarly, angle C of triangle ABC is equivalent to angle F of triangle DEF, and the side BC of this triangle is equivalent to your side EF of this triangle. These two triangles are given to us. Two angles, corresponding angles, and the included side of both the two triangles are equal. Now we have to prove that these two triangles are congruent. So given to us is that two triangles are there, ABC and DEF, in which angle B is equivalent to angle E, angle C is equivalent to angle F, and BC is equivalent to EF. It is given to us. We have to prove that the two triangles are congruent, where A will correspond to D, B will correspond to E, and C will correspond to F. Now for proving it, three conditions could be there. First condition we will be considering. We are considering that AB is equivalent to your DE. We are assuming that the side AB is equivalent to your side DE. This is the first condition. Now it is our assumption that AB is equivalent to your DE. Now if we will be considering these two triangles now, triangle ABC and triangle DEF. In these two triangles, AB is equivalent to DE. It is by our assumption. We have just now assumed that this side is equivalent to this side. So by our assumption, your AB is equivalent to DE. Angle B is equivalent to angle E. It is already given to us in the question. And side BC is equivalent to side EF. It is also given to us in the question. So what is given to us is angle B is equivalent to angle E and BC is equivalent to EF. And we have assumed that AB is equivalent to your DE. So we can see if in these two triangles, this is equal to this side is equal to this side, and this included angle is equal. So we can say by SAS congruency, the two triangles will be congruent. So AB is equivalent to DE, it is our assumption. Angle B is equivalent to angle E, it is given to us. And BC is equivalent to EF, it is even given to us. So we can say that these two triangles are congruent by your SAS congruency. This is the first condition when we have taken AB equivalent to your DE. Now the second condition is when we are saying that if possible your AB is greater than your DE. The side AB is greater than your side DE. This is our second assumption. Three conditions could be there, whether either it will be equal or it will be greater or it will be smaller. These three conditions could be there. So first conditions we have proved when both of them are equal. Now the second condition we are taking when the side AB is greater than your side DE. Now when we are assuming that AB is greater than your DE, in that case there will be some point P somewhere on the side AB which will be equivalent to DE, because it is greater than your DE. That simply means somewhere. Suppose I am saying this is your 3 centimeter and this is your 5 centimeter. Suppose in that case there will be somewhere here a point will be there at 3 centimeter from point B, that is point P, which is equivalent to your side DE. Now we have assumed, we have taken a point P on AB such that your PB is equivalent to your DE. This is our assumption we have taken. We are assuming that side AB is greater than side your DE. And if it is greater, there will be some point P on the side AB which will be equivalent to your side DE. Now we have taken PB equivalent to your DE. It is our by construction we have taken. Now we will be comparing these two triangles, triangle PBC and triangle DEF. These two triangles we will be considering. In these two triangles, PB is equivalent to DE. It is by construction we have taken. Your angle B was equivalent to angle E. It was already given to us in the question. And BC is equivalent to EF. It was also given to us. So we can say by SAS congruency, these two triangles PBC will be congruent to DEF. These two triangles will be congruent by SAS rule. And by SAS rule, if these two triangles will be congruent by CPCT, what we can conclude? That this angle, your PCB, this angle will be equivalent to your DFE, this angle. We can conclude it. This angle will be equivalent to this angle. Remaining corresponding parts will even be equal once your triangles are congruent. So we have proved that triangles are congruent. So by CPCT, we can say that your angle PCB, this angle, this one angle, this angle is equivalent to your this angle. We can conclude it by CPCT. But it was given to us in the question that this angle is equivalent to your this angle. ACB is equivalent to DFE. It was given to us in the question that angle C is equivalent to your angle F. And here, by your assumption, we have just now concluded that this angle is equivalent to your this angle. So why this contradiction is arising? Because of our wrong assumption. Because it is not possible that AB will be greater than your DE. It will be actually AB will be your equivalent to DE. There is no such point P. There is no such angle. This angle, there is not such no such angle is forming, because your this point P will be coinciding your A only. Because of a wrong assumption, all this your problem has arisen. So we can say that angle ACB is actually equivalent to your PCB, and it is only possible while P will coincide your A. That simply means our assumption was wrong. AB is equivalent to your DE only. And if AB is equivalent to DE, we can say that ABC is congruent to your triangle DEF. So this is the second condition when we have taken that AB is greater than your DE. Similarly, this could even be the condition. Third condition could be that AB is less than your DE. In that case, because DE is greater than your AB, we will be taking any point here, somewhere here. Suppose this is your point, say M, such that your EM is equivalent to your AB. And similarly, we will be proving it that it is not possible. It was a wrong assumption. Actually, your M and D are coinciding each other. So this is how it could be proved that two triangles will be congruent if two angles of and one included side of one triangle is equal to two angles and the included side of your other triangle. So in such conditions, your two triangles will be congruent. So this is your second congruency. First we had learned SAS congruency. Another is your ASA congruency. Now here, if we are going to see if these two angles are equal, right? Angle B is equivalent to angle E and angle C is equivalent to angle F. So without proving these triangles to be congruent, can't we say that angle A will be equivalent to your angle D by your angle sum property of your triangle? See, sum of all the three angles of a triangle will be 180. If angle B is equivalent to angle E and angle C is equivalent to angle F, automatically, without proving triangles to be congruent, angle A will be equivalent to your angle D. That simply means we can say that in such type of cases, your side which is equal, it is not compulsorily be the included side. If instead of these two angles, if angle A is equivalent to angle D is given to you and angle B is equivalent to angle E is given to you, and the side which is equal is not the included side, then also the triangles will be congruent. That simply means ASA rule is applicable, but along with that AAS rule is also applicable, because it is not compulsory that the side which is equal should be the included side. If these two angles are equal, or if these two angles are equal to these two angles, then also the triangles will be congruent, because if any two angles of one triangle is equal to any two angles of another triangle, then automatically the third angle will even be equal. So ASA rule is applicable, but along with that AAS also works. It is also applicable. The side is not compulsorily be the included side. So this is like, as we were saying in your SAS, the angle is compulsorily be the included angle, right? It is working, but SSA does not work. But here in this case, because if two angles are equal, the third will automatically be equal. That's the reason this even works. One more thing is, like, if we are saying all the three angles of one triangle is equivalent to all the three angles of another triangle, whether these two triangles will be congruent. So no, AAA congruency does not work. It's not working. Why so? Because see, there are so many triangles could be formed if your angles are equal with the angle 60, 70 and 50. Measure, if the measure of two triangles are, say ABC, this is your vertex is ABC and it is your DEF. Again the measure is your 70, 60 and 50 only. So more than infinite of triangles could be formed with these measurements of the angle. It is not a unique formation. The formation of these angles with these angles, it is not unique. We can make so many triangles with these angles. That's the reason AAA does not work. So till now what we have learned is, we have learned SAS congruency, we have learned ASA congruency, and along with ASA, AAS also works. So these are the congruencies we have learned till now. We'll be doing more congruencies in this chapter only. So let's see one of the question from the exercise 7.1. Say question number 3. I am saying question number 3. AB and AD and BC are two equal perpendiculars to a line segment AB. Show that CD bisects AB. Now over here, this is the figure. First of all, I am making the figure. This is the figure. It is something like this. This is 90 degree given. This is 90 degree given. This is equal to this given. This is O point. This is B point. This is C point. This is A point and this is your D point. Now their equal perpendiculars are given. AB and BC are equal perpendiculars to a line segment AB. Show that CD bisects CD. Your CD bisects your AB. That means we have to prove that OB is equivalent to OA. This we have to prove. It is to be proved. Now how we can prove it? See, if we are going to see these two triangles, one triangle your CBO and another triangle if I'll be seeing your DAO. In these two triangles, I'm just writing it out, triangle CBO and triangle DAO. If we'll be seeing these two triangles, BC of this triangle CBO is equivalent to DA of triangle DAO. It is given to us. Angle B, this angle CBO is equivalent to angle DAO. Both are 90 degree. It is given to us. And this angle, suppose this is angle 1 and this is angle 2. So they are vertically opposite angles. So these two angles will be equal. So angle 1 will be equivalent to angle 2. They are vertically opposite angles. So in these two triangles, see AAS, this side is not the included side between the angles. So AAS by AAS congruency, we can say that triangle CBO will be congruent to triangle DAO. Now the corresponding sides, CB corresponds to your DA, BO corresponds to AO and OC corresponds to your DO. And what we were to prove is OB is equivalent to OA. So by CPCT, we can conclude that OB will be equivalent to your OA and OC will be equivalent to your OD. Corresponding parts, remaining corresponding parts will even be equal. So this is how by any of the congruency rule we can prove triangles to be congruent. Now let's understand some of the properties of a triangle. We know that a triangle is known as isosceles triangle if two sides of a triangle are equal. Then it is said to be an isosceles triangle. And if all the three sides of a triangle is equal, we say it to be a equilateral triangle. So here we'll be understanding some of the properties of an isosceles triangle. Theorem 7.2. Angles opposite to equal sides of an isosceles triangle are equal. It is given to us that the triangle is an isosceles triangle. That means two sides of the triangle are equal. It is already given to us. We have to prove that the angle opposite to the equal sides are equal. So what we have done is we have taken a triangle ABC in which AB is equivalent to AC. This we have taken because it is an isosceles triangle. So we have taken two sides to be equal and we have taken AB is equivalent to AC. We have to prove that the side angle opposite to side AB, that is your angle C, is equivalent to angle opposite to side AC, that is your angle B. We have to prove that angle B is equivalent to angle C. This we have to prove. So how we can prove it? Given to us is that there is a triangle ABC in which your AB is equivalent to AC. It is given to us. We have to prove that angle B is equivalent to angle C. This we have to prove. So what we will be constructing is from A, we will be making an side AD which will be bisecting your angle A. That means AD is bisecting your angle A. Angle A is bisected by your side AD. That means if angle 1 will be equivalent to your angle 2. If AD is bisecting angle A, that means this angle 1 and this angle 2 will be equal in measurement. So construction is AD bisects angle BAC. That means your angle 1 will be equivalent to angle 2 by construction. Now if we will see the two triangles BAD and triangle CAD. In these two triangles BAD and CAD, we can see that AB of triangle BAD is equivalent to AC of triangle your DCA. This AB is equivalent to AC in both the two triangles as it is given to us in the question. Now this angle 1 of triangle BAD is equivalent to angle 2 of triangle CAD by construction, because we have drawn AD the bisector of angle A. So by construction we have taken angle 1 equivalent to angle 2. And we can see AD is common for both the two triangles. So AD is equivalent to AD. It is common for both the two triangles. So what we can say is this side, this angle and this side. So by SAS congruency, these two triangles BAD will be congruent to your triangle CAD. By SAS congruency rule, these two triangles will be congruent. Now if these two triangles are congruent, so over here what we can see is B corresponds to C, A corresponds to A and D corresponds to D. That means angle B will be equivalent to angle C because it is your corresponding part. So once we have proved the triangles are congruent, we can say by CPCT their remaining corresponding parts will even be equal. That means angle B will be equivalent to angle C. And that was to be proved. So this is how we can prove that the angles opposite to equal sides of an isosceles triangles are also equal. Now let's see the another theorem, that is your theorem 7.3. Just converse of it is the sides opposite to equal angles of a triangle are equal. It is given that two angles of a triangle are equal. Angle B is equivalent to angle C. It is given to us. We have to prove that the side opposite to this angle B, that is your AC, will be equivalent to side opposite to this angle C, that is your AB. We have to prove that AB is equivalent to AC. Given to us is angle B is equivalent to angle C. It is given to us. So given is the sides opposite to equal angles of a triangle are equal. Given is triangle ABC is there in which angle B is equivalent to angle C. It is given to us. We have to prove that AB is equivalent to AC. This we need to prove. Again the same construction we will be doing. We will be making AD which is going to bisect this angle A. AD will be bisecting your angle A. That means by construction this angle 1 will be equivalent to your angle 2. It is by construction we have taken. Now proof we will be doing. Again we will be taking the two triangles, your triangle BAD and triangle CAD. These two triangles we will be considering. The triangle BAD, angle B of triangle BAD is equivalent to angle C of triangle DCA. This angle are equal. It is already given to us in the question. AD is common for both the two triangles and this angle 1 is equivalent to angle 2 by construction. So in these two triangles, AD is equivalent to AD, it is common. Angle B equivalent to angle C, it is given to us. And angle BAD, this means angle 1 is equivalent to angle 2 by construction we have taken. So what we can say is angle side by AAS. These two triangles will be congruent. So by AAS congruency, your triangle ABD will be congruent to triangle ACD. Now the corresponding sides are your AB corresponds to your AC, BD corresponds to CD, and AD corresponds to AD. So we can say that AB will be equivalent to your AC. Once we have proved that the triangles are congruent, by CPCT we can say that the corresponding parts will even be equal. So the corresponding parts are your AB and AC, they are the corresponding sides. So AB will be equivalent to your AC. This is how we can prove it. Now let's see one of the question from your exercise 7.2. That is question number 4 we are taking. Triangle ABC is a triangle in which altitudes BE and CF to sides AC and AB are equal. Show that triangle ABE is congruent to triangle ACF. First of all, we are drawing the diagram figure. We are making it as it is given to you in the question. This is your triangle ABC. This is the perpendicular altitude. It is E. This is again an altitude. It is your F. Now it is given that in the triangle altitudes BE and CF two sides AC and AB are equal. Means given to us is BE is equivalent to CF. It is given to us. And we have to prove, first part is triangle ABE is congruent to triangle ACF, and the second part is AB is equivalent to AC. That means we have to prove ABC is an isosceles triangle. Now see over here in the triangle, first of all a triangle ABC is given. CF is the altitude on the side AB and BE is the altitude on the side AC. It is given to us that these altitudes are equal. BE is equal, this BE is equivalent to your CF. Now we have to prove triangle ABE is congruent to triangle ACF. So we are considering these two triangles, triangle ABE and triangle ACF in these two triangles. ABE, this triangle we have considering, this triangle and this triangle. Your ACF. In these two triangles, already it is given to you that in the triangle ABE, the side your BE and the side CF of triangle ACF, they are equal. It is already given to you in the question. So it is given that BE is equivalent to your CF. It is given. Now we can see over here that angle E, that means BEA is 90 degree and your CFA is even your 90 degree because it is altitude. So it is already given to you that these are 90 degrees. So in this triangle, angle AEB is equivalent to angle CFA. Both are your 90 degree. Now in this triangle ABE, this angle A, and again in the triangle your CFA, angle A. Angle A is common for both the two triangles. So angle BAC, not first we are taking this triangle, no? So BAE is equivalent to angle FAC. That is your common for both the two triangles. So what we can say is this angle and this side. That means by angle side we can say the two triangles are congruent. So we can say by AAS congruency triangle ABE is congruent to triangle ACF. These two triangles are congruent. First part we have proved. Now once we have proved that the triangles are congruent, by CPCT what we can conclude? The corresponding parts will be equal and the corresponding side is your AB, and AC are the corresponding sides. So by CP/CT, we can say that AB will be equivalent to your AC. That means it will be an isosceles triangle. So this is how, by using any of the congruency rule, we can prove the questions. Now let's understand some more criteria of congruency of triangle. Theorem 7.4, SSS congruency rule. If three sides of one triangle are equal to three sides of another triangle, then the two triangles are congruent. That means if there are two triangles, suppose this is one of the triangle and this is another triangle. This is your triangle ABC and this is your triangle PQR. And three sides of this triangle are equivalent to three sides of another triangle. So that means your AB is equivalent to PQ, BC is equivalent to QR, and AC equivalent to your PR. If this is the case, then the two triangles will be congruent by SSS rule, that is side congruency rule. The two triangles will be congruent. So what we had learned till now, so your SAS congruency we have learned. In this, your angle should be the included angle. We have learned your ASA, in which it is not compulsory that the side should be the included. So that's the reason your AAS also works. Now here it is your SSS congruency. That means if two sides and one angle we are considering, then always and always your angle should be the included angle. If your two angles and one side is there, in that case it is not compulsory that the side should be the included between the angles. It could be your ASA also and it could be your AAS also. The another criteria is your SSS congruency, that is your side congruency. But as we have already discussed that AAA congruency does not work. If all the three angles of one triangle is equivalent to three angles of the other triangle, then they are not always be the congruent. So we are not going to consider this as the criteria for the congruency. So it is your SSS congruency. Now the next is your theorem 7.5, that is your RHS congruency rule. R over here is right angle, H is hypotenuse, and S is your side. So we are talking about a right angle triangle. So if in two right angle triangles, the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. Hypotenuse should be there. It's not like two sides would be there. Hypotenuse and one of the side will be equal to hypotenuse and one of the side of the other triangle. If this is the condition, then the triangles will be congruent by your RHS rule. So what it says is like this. Suppose this is one of the right angle triangle and this is another right angle triangle. This is your ABC, this is your PQR. This angle B is 90, this angle Q is 90. So hypotenuse has to be equal if AC is equivalent to your PR, and suppose your AB is equivalent to your PQ. If these are equal, it is given to us that AC is equivalent to PR, that is hypotenuse are equal of two triangles, and one of the side I am taking AB equivalent to your PQ. And obviously because it is a right angle triangle, so one of the angle will be 90 degree. Over here angle B is equivalent to angle Q, which is your 90 degree. So by RHS rule, they will be congruent. Over here we can see that the two sides and one angle is there, but here angle is not the included angle. This angle is not in between the two sides which we are considering, but still they are congruent because it is the property of your right angle triangle. In the normal cases, if it is a normal triangle, if it is not a right angle triangle, then in that case for two sides and one angle, your angle should be the included angle. For SAS congruency, your angle should be the included angle. But here in the case of right angle triangles, if hypotenuse of two triangles and one of the side of two triangles are equal, in that case also they are congruent by your RHS rule. Here this angle is not included between the given sides. Still they will be congruent. So this is your RHS congruency rule. So how many congruence rules we have learned? SAS, important is angle should be included. ASA, AAS, side, SSS, and your RHS, that is right angle, hypotenuse, and side. So these all are the criteria of congruency of triangle. If by any means, any of these means, we will be proving that the given two triangles are congruent, so we can conclude that the corresponding parts, remaining corresponding parts, will even be equal, right? It is very important to write their corresponding. Correspondence should be very importantly written. That means whatsoever the order we are writing, where symbolically we are representing, that order is very important. So by SAS, side angle side, by angle side angle, by angle side, by side, or by RHS rule, we can prove any of the given two triangles to be congruent. And once we have proved by any of these means that the given triangles are congruent, we can conclude that by CPCT, their remaining corresponding parts will even be equal. This is how the questions will be solved. We will be proving triangles to be congruent, and then whatsoever the corresponding parts will be there, they will be equal. Now let's take one of the question from your exercise 7.3. That is your question number 3 we are considering. Here, two sides AB and BC and median AM of one triangle ABC are respectively equal to sides PQ and QR and median PN of triangle PQR. Show that the triangles are congruent. First of all, we are making the figure as it is given to you in the question. This is your triangle ABC. Here it is AM is the median. Here it is your PQR and PN is the median. It is the median, so it should look like median. N over here. So it is given to you that AB is equivalent to PQ. Your BC is equivalent to your QR and AM is equivalent to your PN. It is given to you. Two sides AB, BC and median AM of one triangle ABC are respectively equal to PQ, QR and median PN of triangle PQR. Show that first part which is to be proved is triangle ABM is congruent to triangle PQN, and the second part is triangle ABC is congruent to triangle PQR. These are to be proved. Now see over here, first of all we are considering the first part, that is we are considering in triangle ABM and triangle PQN. Triangle ABM, this triangle we are considering, and triangle PQN we are considering. We are considering these two triangles. Now in this triangle, your BM side, one of the side is your BM. Over here in this triangle, one of the side is your QN. What is given to us is that AB is equivalent to your PQ. It is given to us that these two sides are equal. It is already given to us in these two triangles. Along with that, it is also given that AM is equivalent to your PN. It is also given to us. Now, it is also given that BC is equivalent to QR. When BC is equivalent to QR, what median is? Median is the line which is bisecting the side. That means if from the point A, we will be drawing the median on the side BC, then it is going to bisect the side. That means M is the midpoint of BC. Similarly, because PN is also median, that means N is the midpoint of your QR. So if BC is equivalent to QR is there, so half of BC will even be equivalent to half of QR, right? And half of BC, because M is the midpoint of BC, so half of BC could be your BM. BM will be equivalent to half of QR will be your QN. They will even be equal. So first thing is your AB was equivalent to PQ. It was given to you in the question. AM is equivalent to PN. It is even given to you in the question. And it is given that BC is equivalent to QR. But over here in the triangle ABM, and PQN. We are using the sides BM and QN. We are not using the side BC and your QR. So when sides are equal, so half of the side will even be equal, and because AM is the median, that means M point is the midpoint of your BC. Similarly, N will be the midpoint of your QR. So if BC is equivalent to QR, in that case half of BC will even be equivalent to half of QR, and that means half of BC means BM and half of QR means your QN. They will even be equal. So in this triangle ABM and triangle PQN, AB was equivalent to your PQ first, second is AM is equivalent to PN second, and third is your BM is equivalent to QN. So by SSS congruency, we can say that triangle ABM will be congruent to triangle PQN. These two triangles will be congruent by your SSS congruency. Now, if the triangles are congruent, then what we can say? Their corresponding parts will be equal. Over here, A corresponds to P, B corresponds to Q, and M corresponds to N. That means angle B will be equivalent to angle Q. This angle B will be equivalent to angle Q. By CPCT, we can conclude it. Right? Now the second question we'll be taking. We are considering triangle ABC and triangle PQR. These two triangles we are considering, the whole triangle ABC and triangle PQR. In these two triangles, AB is equivalent to PQ, already given to us. AB is equivalent to PQ, it is already given to us. Similarly, BC is equivalent to QR. BC is equivalent to QR, it is also given to us. And just now we have proved, suppose this is your equation number 4. So just now we have proved that angle B will be equivalent to angle Q. So angle B of triangle ABC is equivalent to angle Q of triangle PQR. Angle B is equivalent to angle Q by your equation number 4. Just now we have proved it. So we can see by SAS congruency, the triangles will be congruent. So we can say by SAS congruency, the triangle ABC will be congruent to triangle PQR. So this is how, by using any of the congruency rule, we can prove the triangles to be congruent. Till now we have seen equalities in a triangle, that means equalities of sides, equalities of angle. Now we'll be learning about inequalities in a triangle. So now let's see the theorem 7.6. If two sides of a triangle are unequal, the angle opposite to the larger side is larger or it will be greater. That means if there are two triangles is there, one triangle is there, this is the triangle. Over here we can see that this side, suppose it is your 7 centimeter, this side is your 6 centimeter. So over here we can see that the side BC is greater than your side AC. So the angle opposite to greater side will be greater or will be larger. So if BC is the larger side, is the biggest side, then the angle opposite to it will even be larger or it will be greater. That means if this side AC is smaller than your BC, then this angle opposite to this side AC, that is your angle B, will be less than your angle A. Here we can see that BC is greater than your AC. So we can say that the angle opposite to side BC, that means angle A, will be greater than angle opposite to this side AC, that is your angle B. Hope it is clear that if two sides of a triangle are unequal, these two sides of a triangle are unequal, then the angle opposite to the larger side is larger. The angle opposite to the larger side, this is the larger side in this triangle, so angle opposite to this larger side is angle A, and angle opposite to this smaller side, that is AC, is your B. So angle A opposite to your larger side will be larger or will be greater. Theorem 7.7. If any triangle, the side opposite to the larger angle is longer, that if instead of sides, angles are given to you. Suppose this angle is say 70 degree and this angle is say your 60 degree. If these are the measure of the two angles of a given triangle, suppose this is your ABC is the given triangle. In this triangle, angle B is 60 degree, angle C is your 70 degree. So side opposite to the smaller angle will be smaller and the side opposite to larger angle will be larger. Over here we can see that angle C is greater than your angle B. Angle C is 70 degree and angle B is your 60 degree. So side opposite to this angle C is your AB. AB will be greater than your side opposite to this angle 60 degree is your AC. Then it will be greater than your AC. That means if any triangle, the side opposite to the larger angle is longer. This is the larger angle. So side opposite to this larger angle will be longer than the side opposite to the smaller angle. Then theorem 7.8, the sum of any two sides of a triangle is greater than the third side. So we can construct a triangle if this is your ABC, if sum of any two sides is greater than the third side. If this is a condition which is fulfilled, then only we can construct a triangle. That means if AB plus BC is greater than your AC, AB plus BC is greater than AC, or we can say BC plus AC is greater than your AB, BC plus AC is greater than AB, or we can say AC plus AB is greater than your BC. If these three conditions are fulfilled, then only we can construct a triangle. We cannot construct a triangle with the sides 2, 3 and say 7, because if I'll be joining these two sides with the measurement 2 centimeter and 3 centimeter, so 2 plus 3 is less than your 7. So it is not possible to construct a triangle with these sides. So that's the reason if we want to construct a triangle, if sum of two sides of a triangle is greater than the third side, if this condition is fulfilled, then only we can construct a triangle. Hope it is clear to you that if two sides of a triangle are unequal, one is lesser or one is greater, in that case angle opposite to greater side will be greater. This is the greater side over here in this triangle. So this is 7 centimeter. So angle opposite to this 7 centimeter, that is angle A, will be greater than angle B, which is opposite to side AC. Similarly, if in a triangle two angles are given to you, then the side opposite to greater angle will be greater or longer. Over here we can see this angle is 60 degree, this angle is 70 degree. So 70 degree is more than your 60 degree. So side opposite to this 70 degree, that is your AB, will be greater than your side opposite to 60 degree, that is your AC. And if in any triangle the sum of any two sides is greater than the third side, if this condition is fulfilled for all the three sides, then we can construct such type of triangles. Now let's see one of the question from your exercise 7.4. That is question number 1 only we are considering. Show that in a right angled triangle, the hypotenuse is the longest side. See, right angle triangle means one of the angle is your 90 degree. This is A, B, C triangle in which angle B is your 90 degree. Now we have to prove that AC is that is your hypotenuse, is the longest side. This we have to prove. Now we know that in a triangle, sum of all the angles is your 180 degree. That means angle A plus angle B plus angle C is your 180 degree. And over here angle B is your 90 degree. So if I'll replace angle B by 90 degree, so angle A plus 90 plus angle C is your 180 degree. So we can say angle A plus angle C will be 180 minus 90. That is your 90 degrees. Now sum of the two angles, that is your A and C, is coming equivalent to 90 degree. That simply means the value of both individually, if I'll be taking angle A also, or individually I'll be taking angle C also, in both the cases your value of angle A and angle C will be less than 90 degree. If angle A is 30 degree, angle C will be your 60 degree. If angle A is say 20 degree, it will be your 70 degree. So whatsoever the values of A and C will come, they will be less than your 90 degree. And over here angle B is 90 degree. Now we can see over here that B is the longest angle or the greatest angle in all the three angles A, B, C. And just now we have seen that the side opposite to greatest angle or the longest angle is your longest only. So side opposite to this angle B is your AC, which is hypotenuse. So we can say that hypotenuse AC will be the longest side because it is the side opposite to the longest angle. So this is how we can prove it. So hope it is clear to you how we can prove the triangles to be congruent. This is all from this chapter. Soon we'll be coming with the more videos on other chapters of your class 9th curriculum. Hope it is clear how to solve these type of questions. There won't be any problem in solving these type of questions. Thank you.